Okay, here we are. This is page 8 in the 7th grade instruction book. And our learning target for today is I can add positive and negative integers. And so we are going to talk through these problems as a class and write your answers below. And so let's talk through this as a class. So the first thing that I'm going to do on number 15, since it says compare, showing 7 plus negative 3 on a number line, and showing negative 3 plus 7 on a number line, is that we are going to draw two number lines. So we're going to go here and make them plenty big, go along the page here, and we're going to put 0 here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and negative 1, negative 2. Follow along as I am doing this. Go ahead and do this in your workbook. Negative 3, negative 4, negative 5, negative 6, negative 7, and I only got to negative 8 on that side, but we're going to do the same down here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and we'll get to negative 9 on this one. So these are our two number lines here. And so on the 7 plus negative 3, we're going to start at 7. So if we start at 0 and go this way to 7, and then go backwards 3, 1, 2, 3, where do we end up? We end up at 4. And now, if we look at the next problem, which is negative 3 plus 7, and we start at 0 and go to negative 3, so we start there. And then we go plus 7, and we say 1, 2, 3, 4, 5, 6, 7. Where do we end up? At 4. So now we're going to take a second and say, what do you notice about the results? Explain why you think your observation is true. So go ahead and let's talk about that answer for a second. Okay. So I am going to write what I notice about the results is that the results of both expressions, and that's what this is. This is an expression. 7 plus negative 3 is an expression, and negative 3 plus 7 is also an expression. And I'm going to write the result of both expressions is positive 4. And why do I think that my observation is true? And the reason that this is true is because it doesn't matter what order you add numbers. That's a B. Okay. So then if we look at number 16, we want to explain that Chase drew the number line below to show -4 plus -3. Is his model correct? And if not, then we need to be able to say what's wrong with this model. So let's talk about that a little bit as a class. Okay, so the reason why this is not correct, so the first answer to this question is his model accurate? That answer is no, it is not accurate. And then we want to tell what is wrong with his model. And the thing that is wrong with the model is that both arrows start at 0. So if you're looking at this and notice that both of these arrows here start at 0, and they're supposed to, the way that this would be correct is that the second arrow should start where the first left off. So if this was going to look accurate, and I'll do it in orange, we would start with -4 here. That would be our first look at the arrow. And then we would start or continue from -4 and go 1, 2, 3. So the correct answer would be -7 there. But to answer this question is that no, Chase was incorrect in how he drew his model. And what was wrong with his model is that both of the arrows start at 0, and the second one should have started at -4. Okay, moving on to number 17. On the number line below, the numbers x and y are the same distance from 0. What is x plus y, and explain how you found your answer. Okay, so to answer this question, one of the things that we need to remember is that we talked about that when you add opposites together, they equal 0. And so one of the ways that we could look at this problem is if we said this is 1, 2, 3, so that would be -4 because it's going this direction. And this would be 1, 2, 3, +4 going this direction. And so one of the answers that we could put in this one is that -4 plus 4 equals 0. Or 4 plus -4 equals 0. And remember, when we write the negative number as the second number that you're adding, we've got to put the parentheses there to separate it from the plus sign. So another way that you could have answered this would be to say that if x and y are the same distance but are on opposite sides of 0, then they are opposite values, and they would add to 0. So that's another option of a way to answer it. So this is one option. That's another option. There's a third option that I'll write over here, and it is that -4 and 4 are, and this is a vocabulary word, additive in, there we go. I just pushed something. This is getting crazy. Additive. Oh man. Oh man. All right, let's see if we can get this. Additive inverses of each other. Let's see if as a class if we can give some more examples of additive inverses. All right, and now finally we want to complete this task. Mari is participating in the National Lemonade Stand Day. She spends $18 for startup costs, which include supplies to make the lemonade, cups, and advertising. So there's a couple parts to this question that we want to work through. And one of the parts is part A. Describe in detail how Mari could end up with the lemonade stand breaking even. So that means breaking even means a profit of 0, so that she wouldn't lose the money that she spent, but she also wouldn't make any money. So how could Mary end up with the lemonade stand breaking even, or that she makes enough money to pay for her startup costs but has no money left over? So that's what breaking even means. Your description must include the cost of each type of supply, lemonade, cups, and advertising, with each cost represented as a negative number and in dollars. The price Mari charges for 1 cup of lemonade in dollars, the total amount of sales in dollars, the money she has left over after covering her startup costs in dollars, and a mathematical expression and a model that uses the concepts in this lesson to show the amount of profit. Whew, that's a lot. So let's take that all one step at a time. Okay, so let's say, and we get to make up what she spends. So she spends some money in lemonade. She spends some money in cups, and she spends some money in advertising. And so go ahead and make up, for your problem, the number of, or the amount that she spends in each of these. Okay, now, so I'm going to make up mine, and I'm going to say that she spends $10 in, so that's going to be minus, let's see, we'll put the dollar symbol first, minus $10 because it's something that she's paying for, and so she's not going to have that anymore. And she spends minus $4 in cups, and then another minus $4 in advertising. And over here, I'm going to make sure that negative 10 plus negative 4 plus another negative 4. And so if I was on a number line like we've been practicing, I would, here's 0, and I started at negative 10, and then went 1, 2, 3, 4, that would be negative 14, and then 1, 2, 3, 4, that would be negative 18. So that's my right number. So I have the right numbers for her, how much she spent for her startup costs. And now, how much does she charge for a cup of lemonade? Go ahead and choose in your problem, how much should she charge for a cup of lemonade? I am going to choose to do $1. So 1 cup of lemonade let's say one sale of lemonade equals $1. So that's a positive $1. And so how much is she going to have to sell to break even? And so, and then write a mathematical expression and model that uses the concepts. Okay, so what we're looking at here then is I'm going to draw a number line, and here's 0. And I'm just going to start at negative 10, and it's going to look just like this number line here. Negative 11, negative 12, negative 13, negative 14, negative 15, negative 16, negative 17, and negative, I got to get to 18. Negative 18, and I'll redraw my line from here. Okay, so this is all of the money that she spent this way. So this is what she spent for lemonade. And then this is what she spent for cups. Oops. And this is what she spent on advertising. And so the question is, describe how she could break even. So far we've described she spent $10 on lemonade, 4 on cups, another 4 on advertising. And then she must sell. So for every sale, she gets $1 back. So she has to sell 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So she must sell 18 cups of lemonade. Okay, so we've got the model part. That's this part down here. So when it says draw a model, a number line is one option that we could choose. And then a mathematical expression. So we'll circle that in blue, and we'll come down here. This is what the mathematical expression of this would look like. It would be -10 plus -4 plus -4. So that's our cost of the lemonade and our cost of the cups and our cost of the advertising. And then if we add 18 to that, because that's the cost, that's the profit that she made, or the amount that she made on every cup that she sold. So if we do that, then that ends up equaling 0. So that's how that problem works, or part A of that problem. Part B says repeat part A for the situation where Mary's lemonade stand makes a profit. So makes a profit means, whoops, that's the wrong, there we go. Makes a profit means she has enough money to pay for her startup costs and has money left over. So we have a number line here, and so what would need to be different about a new number line with all the same information for her to make a profit? Talk about that for a second. Okay, so here's what this means, is that if she sells one more cup of lemonade, if she sells 19 cups of lemonade, if they're $1 each, then she makes a profit. So if she sells 19 cups of lemonade, then she will make a profit if she sells the lemonade for $1 per cup. All right, and that is our work for today.